Welcome back. In this session, I am going to discuss about some of the factors we need to consider uh, when we design any microservice. Okay, let's consider. Okay, I have an application via which I can sell my product. Okay, I can sell my product via uh, the call center. Okay, customer can call the call center agent and they can buy the product, or they can also come to the store and they can buy the product. Okay, in both the cases, okay, if they are buying the product they have to pay for the equipment, and if they are buying the product in installment basis then they have to pay monthly bill. Also they can set up a auto payment. Okay, so this is applicable even for the store. The same functionality is applicable for the store. Okay, so in all these cases, okay, the one thing which is very common is they have to do a payment, right? So that's why I thought I can develop a microservice called payment microservice, and I can make use of this microservice across these layers. Okay, so now let's discuss about what are the different factors. Okay, I am considering to develop this microservice, right? So as I said, I need to make use of this particular microservice in both my application, in the call center and also in the store. So in that case I need to make sure that my microservice is um, in case if I am developing another application, okay, and if I want the same payment microservice reusable in that microservice, okay, in that case also, okay, I need to make sure, okay, this payment microservice is reusable. So altogether, okay, as long as you are going to develop a microservice as a reusable component, then you are good enough. The second point is, okay, let's assume I'm developing this payment microservice for a call center application. Okay, so in future, if I am going to make use of the same payment microservice for a store, I need to make sure, okay, whatever the changes I'm going to do for store should not impact the call center. My microservice should be loosely coupled to any of the application. So that's the second factor. It should be loosely coupled. It should not be bind to any of the application. Okay, so my services should be independent to support any of my clients. Okay, so that is the second factor. The third one is whatever resource you are going to use for your application, it is better to have your own resource. Each microservices should have their own resources. Okay, for example, if let's consider, okay, I am so let's consider I have another microservice and I am having another data, like I'm going to consume the data. I'm going to make use of uh, the database in that microservice. Okay, I'm going to make use of a database in that microservice. Okay, in case if I want to take this microservice, I want to use this microservice for another application. Okay, so in that case, since it is kind of depending on the another resource on the another application, okay, I have to take both the microservice to make it reusable, right? So I have to take everything together uh, to make to make use of my microservice in another application, right? So that is why it is better to have your own resources. Okay, another advantage of having your own resources is you can avoid the latency and improve the performance. For example, if I am going to make use of the database in another microservice, so I have to send a request over the network to another microservice and get a response back, right? So there is a network call which may impact the performance of your microservice. The latency should be impacted. Okay, so that is why it is always better to have your own resources. Okay, So that's a third one, okay, which we call as a autonomy. We have to consider about autonomy, okay. And the next one is, let's say your payment microservice is servicing for five clients today, okay, but later on you may be getting a request from thousands of clients, okay. So you should be capable of supporting all the requests, okay, without impact in the latency, okay. So all the clients should be satisfied by the way you are sending the response, okay. So even in case like uh, the application, the microservice crashed, okay, in that case also you need to be responsible enough. We need to make sure our microservice should be auto scalable and we have the fault tolerance mechanism in place, okay. This the Spring Boot world, we have a load balancer using the Eureka, and using which we can actually start a number of instances of our microservice. In case of Eureka, it is like Eureka is a server, and all the microservices need to go and register to Eureka. So Eureka will send a request to one of the available instance, okay, based upon it used the ribbon technology to transfer the request to one of the available instance. So that is what that is how it works in the Spring Boot world, okay. We on top of that we have something called history circuit breaker, okay. So this is for the fault tolerance. In case one of the instance failed, okay, we should be responsible enough to send a response as soon as possible instead of waiting too many requests coming to the same instance and and getting crashed, right. So instead of that, what we can make use of this history circuit breaker framework, which can send the response back to the client in case of failure of any of the instance. So uh, so altogether the auto scaling and fault tolerance mechanism should be um, applied to our microservice, and then it should be discoverable, means like any client, okay, they should not be knowing like what is the port, in which port your payment microservice is running, like the port should be dynamic, right. So your client don't know like uh, what is the actual URL to run the to send a request, right. So in that case we can make use of some discoverable framework, something like Eureka. So where once the client send a request, the Eureka knows the mapping, like the Eureka knows to which instance it need to forward the request, okay. The client doesn't need to worry about um, how to hit the instance. The Eureka will take care of that in this case, okay. So you need to have some kind of a discoverable mechanism in place to take care of all the requests, okay. And the final one is your microservice would be composable. When I say composable, let's say like I have my microservice ready, okay, and someone want to make use of my microservice, okay. So they need to consume the services, the endpoints I'm going to provide them, right. For example, here, right. So bill payment, like they need to send the submit, they need to submit a payment and they need to get the confirmations, and based on the confirmations they need to display the successful page, right. So I should be providing a lot of endpoints to my client, okay. So the client should be aware of what are the different endpoints I am providing, right. So that we can in the Spring Boot world we can achieve using the Swagger. In the Swagger, when coding itself, you need to do some configuration so that it will create the API document for you. The documentation is user friendly. The users can see what are the different endpoints, what are so for each endpoint what are the different inputs you need to provide, what is the response you are getting, and you can also test each of those endpoints by sending some sample data. So that way, so using Swagger, you can easily share your microservice with a number of clients for them to start consuming your microservice. Okay. So altogether, like your microservice should be reusable. As I said, it should be reusable. It should be loosely coupled. It should be autonomy. It should be fault tolerance. It should be discoverable, and it should be composable. So these are the different um, factors we have to consider. On top of that, there might be few more factors. Uh, if you guys think like if I am missing any of the critical factors, you guys can share that in my comment so I can also think about those factors. Thank you. Bye.